Hey everyone, welcome back to Number Playground. Puzzles, patterns, and proofs. How many diagonals does a 20-gon have? 20 vertices, 20 sides, and honestly a lot more diagonals than most people guess. Let's not overthink it right away. We'll build the answer up piece by piece, starting small. First, let's build our test case, a friendly little pentagon, 5 vertices, numbered 0 through 4. A side's the easy part. It just connects two vertices sitting right next to each other. Like this one between vertex 4 and vertex 0. A diagonal's the interesting one. It connects two vertices that are not neighbors. And we'll always draw these as arrows so you can actually see where they're pointing, like this, from vertex 0 to vertex 2. So really, the whole question boils down to this. How many of these gold arrows show up once we scale from 5 vertices to 20? All right, let's stand at one vertex. Vertex 0 lit up in gold. From here, there are n-1 other vertices we could possibly reach. That's 4 of them for our pentagon. But hold on, 2 of those 4 are basically right next door. This side connects vertex 0 to vertex 1, and this one connects vertex 0 to vertex 4. Both of those are already sides, not diagonals, so they don't count and we've got to take them out. Put that together, start with n-1, then knock off those 2 neighbors, and the algebra simplifies to n-3. That's the general rule for any polygon. Plug in 5 and vertex 0 has exactly 2 diagonals, leaving it right here in gold. And here's the nice part. Every single vertex on any polygon follows that exact same rule. Now here's the fun part. Let every vertex do this at the same time. Watch all the diagonals light up as gold arrows, each one heading out from its own vertex. 5 vertices, 2 diagonals apiece. That's 5 times 2, or 10 arrows total. Now look closely at just this one diagonal between vertex 0 and vertex 2. It got counted once as an arrow leaving vertex 0, and then counted again as a second arrow, leaving vertex 2 and pointing back the other way. Every diagonal has 2 ends, so really, all 10 of those arrows are double counting the real diagonals. So we divide by 2 to undo that, and the pentagon ends up with exactly 5 diagonals. Let's double-check by just counting them ourselves, one at a time. 1, 2, 3, 4, 5, and look, that's the little star inside. Formula checks out. Nice. We just proved this rule works, start to finish, on a real example. And here's the thing. Nothing about that logic was specific to pentagons, so let's trust it completely and scale it up to 20 vertices. Same formula, bigger shape. 20 vertices this time. Check it out. Watch how many diagonals fan out of just this one corner. 17 of them, and -3 exactly like we just saw with the pentagon. Same formula, 20 times 17 divided by 2. 20 times 17 is 340. Cut that in half for the double count, and boom. A 20-gon has exactly 170 diagonals. Your turn. How many diagonals does a 100-gon have? Same trick. Solve it small, then scale it up. Drop your answer in the comments, and if this made sense, go ahead and subscribe. See you in the next one.